Howdy, my name is Alex Thompson and I am a junior at Texas A&M University studying biological and agricultural engineering. And today I'm here to talk to you about fog nets. So fog nets have been used for upwards of 1,500 years by human civilization to capture fog and moisture from the air and turn that into water for crops and drinking water. So I have two examples in front of me today. So this is a mesh fog net and this is a solid plastic screen used as a fog net. So these are the traditional fog nets that have been historically used. These are better in more humid climates up in the mountains where there's more fog to capture. And these plastic nets are best when the air does not have as much moisture to capture. In the middle here, I have a temperature sensor. This is the sensor here. This is connected to my laptop, which records the temperature every second and writes it into an Excel sheet. So the temperature is important because as the temperature increases, more water is evaporated from the nets and goes back into the air. And that is not what we want because we want to capture the moisture to water our crops. So as you can see here, if we hold this temperature sensor, the temperature goes up. And so I also have a garden sprayer with me and I'm going to demonstrate how these work. So again, the mesh fog nets are better for more humid environments, such as up in the mountains. These are currently used in the mountains of Peru to capture drinking water. They can capture upwards of 100 gallons of water a day. And as you can see, that water is flowing down into the plant. Now over here, we have our solid plastic net. As you can see, the water starts dripping down into that plant a lot faster because the plastic does not have to become saturated with moisture before the water goes down into the plant. The water hits the plastic and then goes directly down into the plant. So let's dig a little bit more into the setup that we have here. So to secure each of the nets to the plants, I used a wooden stake and taped the net to the stake and put that into the soil around the plant. I also weighed down each of the plants here with rocks. As you can imagine, these nets, once they're set up, end up creating kind of a mast for each of the plants, and they can become quickly unstabilized from the wind. So to remedy this issue, here they go. To remedy this issue, I weighed them each down with rocks. In Peru, as they're used, they are vertical nets secured directly into the ground, and they're typically about 8 feet by 8 feet, and these nets underneath them have a water trough. All of the water is then dripped down into that trough, and that trough is directed into a set of filters to then use for drinking water and make the water potable. Additionally, used in other parts of the world, you can use a humidity sensor. Right here, we just have a TMP 36 temperature sensor. This only does temperature, and instead of this, you could replace this sensor with a DHT 11 sensor. This will measure the humidity as well as the temperature. This is important because as the humidity of the air increases, you can expect to have a greater amount of water collected onto these nets. And from this data, the humidity and temperature, from that, you can determine how much water you will expect to collect each day, as well as measure and keep track of the evaporation rate of that water that you have collected.